Hello and welcome to this tutorial on C. Today we're going to understand the difference between an iterative and a recursive function in C. The case study will be the factorial program to calculate the factorial of a number. And the objective of this lesson is to understand the difference between an iterative and a recursive program. That is the difference between iteration and recursion. What is a factorial program? The factorial of a number denoted by n factorial is the product of all positive integers less than or equal to that number. How is this represented in mathematics? In mathematics, 0 factorial is 1 and n factorial will be equals to n times n minus 1 for all of n when it is greater than 0. For example, 5 factorial is equals to 5 times 4 times 3 times 2 times 1, which is equals to 120. So if you want to get the factorial of 4, for example, it's going to be 4 times 3 times 2 times 1. See, that's how it works. What is iteration? Iteration refers to the process of repeating a set of conditions until a specified condition is met. Very important. You can pause the video, rewind the video as many times as possible to get it. You take your notes to get the concept, and you're going to keep it in your memory because we're going to write a program and you're going to need all of these building blocks, these concepts, to be able to develop it with understanding. How do you construct an iterative program in C? We construct iterative programs with the use of loops. What is a loop? A loop is a statement that repeats a block of code as long as a specified condition is met. In C, we have many loops, but for constructing an iterative program, we're going to use the for loop or we're going to use the while loop. Now, let us go into the proper implementation of the factorial program in C. The first thing is that we're going to include our header. The hash includes standard input output.h. And if you don't know what this means, you go to the previous lessons. I clearly explain what each header does in C. The next thing is that we are going to declare our function. There's another lesson for declaring functions that you can go to the previous lesson and you're going to see. But so what you see here is we are declaring a function called fact, and it takes one argument, which is an integer. So we're telling the computer that inside this program that we're going to use, there's a new function that we are going to be using, and it's called the fact, and it takes one argument inside, which will be an integer. That's simply what this is, function declaration. And we have our main function. In our main function, we are going to declare our variables. We'll declare two variables, number, no, factorial. So these are the two variables that we are declaring in this function, the main function. And notice that, remember that the program starts execution. It begins execution from the main program. So we declare our variables, we'll put our printf statement to enter a number, /n means a new line, and then we're going to read the number into this variable called number, and the address is n. This ampersand means the address, and the variable is number. So the number that will be read will be kept in this variable called no. Now we are going to call our factorial function here, and whatever the number, if the user entered 5, for example, 5 will be executed inside the factorial function because it's the factorial function that we are calling it. So we are putting 5 into the factorial function, and we are assigning the value to this other variable called factorial. The next thing is that we're going to print the factorial. The factorial of percentage d is a placeholder for the first integer, which is the variable number, which 5 is inside, is percentage d. This is the placeholder for the second variable, which is factorial. So in this case, the output is going to be the factorial of 5 is 120, because 120 will be the value that will be kept in this variable called factorial. But that is that for the main function. How do we now write an iterative function now to do all of this logic and the mathematics? How do we do it? All of the logic happens in the factorial function. This is the factorial function here, and we declared it here, so we called it here, and we are defining it. So in functions, you declare functions, you call functions, and you define functions. Now in this function definition, we have our function. This function is actually where the logic takes place. This is actually the iterative function to get the job done. So we have declared our function here. Now we are going to define it here. So we define the function where we explain and give the logic, and we give the dynamics of how everything works. And then notice that we called the function here. So this is where we're going to define it. So to define the function, we put the function, the data type that this function is going to return, which is an integer, and the arguments inside the bracket, it takes integer, and it's an integer value that is going to be able to receive this function. So we declare our variables int I, int f, and we initialize the first variable f to be 1. So in this variable called f, the first value inside is 1. We're initializing 1 to it. We begin our loop. What do we say is a loop? A loop is simply a statement that executes a block of code as long as a specified condition is met. So we begin with, we say I, which we declare here, we declare here to be 1. So we say I is equals to 1, and then this is the condition. So this is the beginning condition, this is the initialization. So a loop has 3 parts. A loop has the initialization, it has the condition, and it has the increment. Some loops will have but the decrement, but in this case we'll have an increment. So the initialization, we say I equals to 1, and then as long as I is greater than or equals to n, we should add I plus 1. So the next case will be I will be equals to 2, because this I plus plus means I plus 1. So the first case is I less than or equals to n. Notice we entered the n here is 5. So is 1 less than or equals to 5? Yes. So we are going to execute the statement f. So we have the old value of f. The old value of f is what? 1. And this other f that is before the equals to sign is the variable that will keep the new value of f. So the old value of f, the first case will be 1 times, what is I? 1. So 1 times 1 will be kept inside of f. 1 times 1, the answer is 1, and will be kept inside. Now the new value that will be kept inside this variable now will be 1. So 1 times 1 is 1, and then now this increment now will go I plus plus, which is 2. Now is 2 less than or equals to 5? True. So what is inside this f now? What is inside this f? Remember, it was 1. What is inside this I now is 2, because it has incremented 2. So it will be 2 times 1, and 2 times 1 is 2. 2 will be kept inside the new, the value that is inside this variable called f will change to 2, and that is how it's going to go. It's going to continue until the value of I is equal to 5, and now the condition is met. So it will come out of the loop and is going to return f. Return f now will be the factorial of 5, because the value that we entered was 5, and it's going to return it. It's going to return the content of this variable called f. That is why when you call this function called fact, we call it here. When you call this function here, it's going to insert the number 5 that you inserted into this variable here. So 5 will be executed inside this function, and when 5 now is going through this iterative loop where it's going to repeatedly multiply every value of n when n is greater than 0, you're going to now have the factorial. It does it a repeated number of times until now we can get the factorial of a program. So iteration has to do with you're repeating a statement. You're repeating a statement to solve a problem. You're repeating code to be able to get a job done. So this is the iterative function to calculate the factorial of a number. In the subsequent slides, we are going to implement it actually in C, and you're going to see how it works. This is not the recursive approach, but the iterative approach to calculate the factorial of a number is very important. We're going to learn the recursive approach in subsequent slides. The code uses a for loop to calculate the factorial by multiplying numbers in a sequence from 1 to n. From 1 to n. This method repeatedly adds to the variable f, which holds the factorial value. That's why we explained it here. Recursive programs would involve a function calling itself to solve smaller instances of the problem. So we're going to come into it. Characteristics of iteration. The first characteristic is process. It uses loops to repeat an action. The next is performance. So iterative functions are more memory efficient because they don't use the call stack. A call stack is a stack in the memory area for subroutines. So a call stack is an actual stack in data structures. It's a data structure where you're going to keep subroutines. So it does not use call stacks. So it's going to be more memory efficient. The next characteristic is the termination. It ends when the condition is met, e.g., reaching the maximum value. That's when the loops are going to end. That is that for iteration. Now, what is recursion? Definition. Recursion is a process where a function calls itself to solve smaller instances of the same program. So already in your mind, you're already seeing a function, and inside that function, you have a call of that function inside that function. So a function is calling itself. A function calling itself to solve smaller instances of the same problem. What are the components of recursion? The first and the most important case is what is called the base case. The base case. The base case serves as a stopping condition for recursion. Where is the program going to end? It's going to end in the base case. So the base case serves as the stopping condition for recursion. It defines the simplest instance of the problem that can be solved directly without any further recursion. So the base case, it is solved without recursion. Very important. The next component of a recursive function is the recursive case. The recursive case is where the function calls itself. See, right? We're going to come to it. Now, let us now implement the recursive function now in C. We are going to begin by putting our header, hash include standard input output.h. We're going to declare our function there. We're going to use the function called fact. We have the main function. The main function, we're going to declare one variable, and that variable is number that will keep the number that is entered by the user, which is no number. So we're going to print f. So this statement now is to print the output. So if the user enters 5, so it's going to say the factorial of 5 is 120. And this is the placeholder for this 5, which was kept in this variable called number. And this is the placeholder for the factorial function that is being called. So how does it work? Now, this is a comment in C. A comment is used to explain a section of a code. This is the recursive function to calculate the factorial of a program. What is recursion? the ability of a program to call itself. So in this function called fact, if it is a recursive function, I need to look into this, it begins from here and ends here. I need to look inside this parenthesis to see if this fact is being called inside of the function. So I can already see here, you see, right, inside this function called factorial or fact, the fact is called inside this function called fact. So it is the ability of a function to call itself. So the fact function is calling itself. The fact function is calling itself. So recursion is the ability for a function to call itself. You see, right? So this is a recursive function. So how does it work? This is the definition of the recursive function that we define here. We're going to say if n, what was inside of n5, if n is the variable that will be received from the user. So if n is equals to 0, or these two lines is or, if n is equal to 0 or n is equals to 1, return 1. The factorial of 0 and the factorial of 1 are equals to 1. So if the user enters 0 or the user enters 1, it's going to return, the answer is what? 1. You see, right? Else, you see, else, return n times the factorial of n minus 1. Simple. So it's going to calculate the factorial of n minus 1. In this case, n was 5. So n minus 1 is 4. So it's going to calculate the factorial of 4 and multiply it by n5. You see, right? And if it takes the factorial of 4 and multiplies it by 5, automatically you have gotten the factorial of 5. And it's going to return this. It's going to return the answer here. And that answer now is called here. So whatever number the user enters, whatever the number the user enters, if the user enters 8, is going to say 8 times the factorial of 7. You see, right? Which it will now give you the factorial of 8 and will be called here, and then is going to be displayed. The answer is going to be displayed. So this is the recursive approach where a function calls itself. A function calling itself. So in this example, the fact function calls itself, which is the hallmark for recursion. So recursion is about a function calling itself, a function calling itself. How do we implement all of this in C? To implement all of what we have learned practically in C, this is code block. This is the environment of code block. It is used to run C code and write C programs. So I just copied what was on the slide and I pasted here. So this is the iterative program. This is the function to calculate the factorial of a number iteratively, you see. And we already explained the logic on the slide. So I'm just going to build and run. Let us take, for example, say enter a number. Let us enter 5. Let me close this. I want it to be, I want the output to be here on the same line. So enter a number. If I enter 5, see, the factorial of 5 is 120. That is very, very correct. And if I run it again and I enter 10, the factorial of 10 is, how much is this? This is 3,628,800. So that is the factorial of 10. So any number that you put is going to be calculated iteratively using this function, and the function is going to be called here, and then the answer displayed here. So for the recursive approach, this is the code, the exact same code that was on the slide. I copied and pasted here, and we can build and run. You'll notice that it's going to give the same answers. the factorial of 5 and the factorial of 5 is 20, and let us see the factorial of 10. The factorial of 10. It is exactly what we had for the iterative program. So in the advanced level practicals, they're going to ask you they can tell you to calculate the write a factorial program that recursively finds the factorial of a number. If they tell you to use recursion, you're going to know that you're going to use this kind of program where a function is calling itself, you see. And then if they tell you to use iteration, you're going to use these while loops are executed repeatedly to do something until a condition, as long as the condition is met. So thank you so much for your kind attention, and see you in the next lesson.